Okay, well, you know what time it is. It's the most wonderful time of the year. That's called finals. You get to avoid all those other classes and actually take some time to really focus on math, which I know you're really all excited to do. So for the final review, I've actually already made a key to this, and so I'll kind of go through it line by line, but rather than writing it out, I'm just going to talk our way through that. So let's check out this very first problem. I've asked us to simplify. My screen jumped to the other side. I've asked us to simplify this problem. So notice that the first thing I did is I wrote it both ways as the binomial twice, and then I used the distributive property. And back from your days in Algebra 2, you might remember that positive 25i squared is actually negative 25. And so 25, negative 25 and 1 makes negative 24. And that's kind of the end of that story. So for question number 2, this is a nice little quadratic inequality. So the first thing that I did is I just looked to see if I could factor it. And it turns out that I can factor this to a 3x plus 1 times a 4x minus 3. And one of the things that I stressed early on in our course is that anytime you have an inequality, we always want to consider that inequality on a number line as a simple graphical organizer. So the two places where the number 0 would occur would be at 3/4 and negative 1/3. That's fairly clear and easy to see. But then if we guessed a number out here to the right of 3/4, like say something like 2 or 10 or even 100, if you plugged in like 10, you would get 31 times 37, which is clearly a big positive number. I don't care what number, I just care that it's not negative. So it's positive here. Try a number in here. Clearly, most people are going to pick 0. You get a positive and a negative. That's a negative. And then I want to choose the portion of the graph that is less than or equal to 0 in here. So we could either write it as an inequality or in interval notation. So that was all values from negative 1/3 to 3/4. It's been a while since we've done that. So notice those square brackets indicating that we can have those endpoints. Now, when we get to problem number 3, it's a little bit of a different question because it asks us to do a cubic, and unfortunately cubics are not something that we actually know how to solve very nicely. Sorry, that keeps moving around on us, but I'm just trying to get that to where we could see. So I went to my calculator and I graphed it, and what I noticed is on my calculator I used this feature right here. After I graphed it, I went to calculate it and I looked at the number 0. And so the way that one works is you plug in your equation and then you move the cursor just to the left of the 0, like right here, hit enter, move it to the right of the 0, hit enter again, and then a third time and it will zero in on that number. Then I did it again, I hit second, calculate the 0, and I moved to the left of the root, hit enter, the right of the root, hit enter twice, and it gave me these answers. And so I repeated that process 3 times. There's really no other way to do that. And I ended up with these 3 places where 0 occurs. But it's not really asking where 0 occurs. It's actually asking me where is the graph below 0, or in other words, negative. And of course, the places where this graph happens to be negative is from negative infinity up until that negative 1 happened. And this little region in here from 0.227 to 0.631. And notice the open parentheses because we're not allowed to actually have that equal 0. We just want to know where it is specifically negative. Now, problem number 4 jumps a little bit further. We're going to be looking at some kind of a fraction buster. So I decided to multiply both of these fractions by 12 because that would make the 4 go away as well as the 6. Since 4 goes into 12 3 times, I reduce this down and just use the distributive property on the number 3. Also, since 6 goes into 12 2 times, I cancel those out and left a 2. So you're going to notice that I have 3 times 5x plus 3 and 2 times 2x plus 1 being 84. this becomes just a very simple distribution with a little bit of combining like terms, and I got a nice easy number of 7. Now keep in mind, on the test, if you were doing that problem, a pretty smart thing to do sometimes is to go in here and say, well, you know what, let's see, did I do that all right? I have 5x plus 3, notice the parentheses around that numerator, divided by 4, minus parentheses 2x plus 1, over 6. And according to what I have done, again, I like, we've mentioned this before, if I go second window, making sure that my calculator is in ask mode, I just found out that my answer was 7. So if I say 7, my calculator says, hey, if you plug in 7, the answer is 7. So that tells me I actually did. I plugged in 7 for x and I got 7 for y. Now, for part B, absolute values, remember, they look like a V. And so since it looks like a V, there's one line that has a negative slope coming down and one line that has a positive slope. And so what happens is we actually look at both the positive and negative case, and we go through there. Now, many people just look at this one on the left and they come up with that answer, and they forget that there's a second answer on the right. Now, again, stressing the use of the calculator as a way to make sure that we're not being silly and forget things. Under the math button, you can go over to number, and absolute value is sitting right there. And we have 5x minus 7, and I want to know where is that equal to 15. But what I'm going to do is I'm just going to set my window, and I'm just going to go ahead and make the window go a little bit higher since I'm wanting to know when it's equal to 15. So there's a couple of ways that we can do this, but one way is to just go ahead and graph it, and I can calculate the value at 22/5. And notice that it actually said the answer was 15. Or I can just hit -8/5 because I'm already in that calculating mode, and it also says -1.6. The other option, if you're a little bit more lost, is you could have gone in here to y equals and set it equal to 15. Now, if we look at the graph, we can clearly see that they cross, and so I could calculate the intersection, move the cursor close, and hit enter 3 times. Now, what I just got when I did that is -1.6, which is that answer. And of course, if I did it one more time, and move the cursor over closer to the other intersection, hit enter 3 times, and I should get 22/5 or 4.4. Okay, so for our last problem on this particular video, question number 5, let's take a look at solving that by the method of our choice. Now, we could solve 4x squared minus 7x equals 1 by either the quadratic formula, by completing the square, or we could do it with factoring. So when I looked at that problem, the first thing that jumps out to me is that it's not equal to 0, so I wanted to make it equal to 0. And I did try to factor, so it didn't work. And since it's equal to 0, the first thing that I personally did is I decided to divide every single piece of this problem by 4 because we really like the leading coefficient to be 1. Now, you guys already know me and know that I love completing the square. So what I did is I took the 7/4 and I cut it in half, which was 7/8. I squared 7/8. That's where the 49 and 64 come from 7 squared and 8 squared. And so we have this little thing where all I did is I added those two fractions together. I used my calculator. I cheated a little bit and I got 65/4. But since this is a perfect square, if I take the square root of both sides, then all I have left to do is add the 7/8 over. Now, some people love this method. Other people like to do opposite b, plus or minus the square root. You could sing a song, do Pop Goes the Weasel, however you need to memorize your quadratic formula, but lots of options to do that. But you're going to notice that in both cases, you get the same answer. And I know a lot of people like this answer and think it's a little bit cleaner. You just have to be very, very careful with your order of operations when you do that. So that's the first 5 questions on the review. Hope it helps. Thanks. See you soon. Bye.